Hello there, it's Justus, your maths and statistics tutor. In today's lesson, I want us to learn about equations of parallel lines. But before we learn about the equations, can we first understand what are parallel lines? I mean, draw two lines in this interactive graph and we observe their behavior. So I can draw line 1, that one, and then I'll draw line 2. So every other time I extend these lines, they keep, increasing, but they don't meet. You see, they never meet. So basically, parallel lines are lines that never meet regardless of how you extrapolate them. They'll never meet at any point. You see, like this. So they never meet. Now that we know parallel lines don't meet, can we study their properties? And actually that is property number 1, they never meet. Property number 2, can we study the gradient, the behavior of their gradient? Let us call the blue line as line 1, I can call it L1, and the red line as line 2. Like that. So, I want to pick 2 points on each of the lines, which I can call as point A, which will have certain coordinates, and point B, which will also have certain coordinates. And I do the same for line 2, like that. For this blue line, let me pick this point, point 2, 10. So I can put it as the first point, 2, 10. And then I pick the next point as point 6, 18. So second point can be 6, 18. Can I do the same to the second line, the red one? Let me pick point 8, 18, 8, 18 here. Put it here. It's the highest point. And then I pick another point, this point, point 4, 10. So point 4, 10. And now that I have the 4 points, 2 points for each line, I can now easily calculate the gradient of each line. If you don't know how to calculate gradient of a line, you can review lesson 2 or lesson 3. You'll understand how to calculate the gradient. But basically, gradient, which for line 1, let me call it M1, is given by change in y all over change in x. It can be y2 minus y1 divided by x2 minus x1. And in this case, we already have all these values. So this is x1, this is y1, this is x2, and this is y2. So I just need to replace them here. So here, if I take y2 is 18, I subtract y1, which is 10, then divide by x2, which is 6. I subtract x1, which is 2. I get 18 minus 10 is 8, and 6 minus 2 is 4. So I get 2. And the gradient of line 1 is 2. How about the gradient of line 2? Let me call it M2. Is still change in y all over change in x, which can be given by y2 minus y1 or 2 minus y1 all over x2 minus x1. But here already have all these values here. So this is x1, this is y1, this is x2, and this is y2. So if I just replace them here, I have y2 as 18 minus y1, which is 10, divided by x2, which is 8, minus x1, which is 4. So I get 18 minus 10 is 8 divided by 8 minus 4 is 4. So the gradient of second line is also 2. So another property, the second property of parallel line is that their gradients are the same. So M1, the gradient of line 1 is the same as the gradient of line 2. So parallel lines have the same gradient. But how about their y-intercept? Let's look at that. Since we already know the gradient of line 1 and the gradient of line 2 are the same and it's equals to 2, we can use any of the coordinates of each of the lines to find the y-intercept of each line. So let's start with line 1. If you don't know how to find the intercept of a line, you can review lesson 3. I taught that concept there. So to find the intercept of line 1, I can just say 1 minus y1 is equals to m which represents the gradient of the gradient, then into x minus x1. So here it becomes y minus y1, but we already know y1 is 10, is equals to m, which we already know is the gradient is 2, into x minus x1, which we already know it's 2. So it becomes y minus 10 is equals to 2x, if I run the brackets, minus 4, which becomes y is equals to 2x. When I take this 10 on the other side I had, so it becomes minus 4 plus 10, so it becomes plus 6. So the y-intercept of line 1, which is represented by b, is 6. This one. Can we do the same on the second line? The process is the same, the equation is the same. So I'll take 1 minus y1, but now for line 2, which is 10 still, 10 is equals to m, which is 2, into brackets, x minus x1, which is 4. So it becomes 1 minus 10 is equals to 2x minus 8, which becomes y is equals to 2x. When I take this 10 on the other side and I had here, it becomes plus 2, because negative 8 plus 10 is positive 2. So the y-intercept of line 2 is 2. The intercept of line 1 is 6. The intercept of line 2 is 2. So parallel lines don't have the same intercept. So to summarize the whole all the properties of parallel lines is they never meet, they have the same gradient, but they don't have the same intercept. So having that knowledge, can we try to solve some questions relating to these parallel lines? So for example, if somebody tells you to find the equation of a line parallel to this line, line given by y is equals to 3x plus 2, and that line we want to find its equation as a certain point, I can call it point A, which passes through 1, 4. We can do so. First, do you realize we already have the gradient of this line, because the normal equation of a line is given by y is equals to mx plus c, where m is the gradient. If you don't understand this concept of find gradient from a line, you can review lesson 3. I taught the concept there. So the gradient here, m, is equals to 3. As since we said parallel lines have the same gradient, then it means the gradient of our line here is also 3. So the gradient of this line, which I can call m1, is also 3. So if I want to find the equation of this one, I can just say this is x1 and this is y1, and then I apply my equation where I said y minus y1 is equals to m into x minus xy. And so you see, I do y minus y1, which is 4, is equals to m, which is 3, into x minus x1, which is 1. And I get y minus 4 is equals to 3x minus 3. Then when I go on, I get y is equals to 3x. When I take this 4 on the other side, it becomes positive, so it becomes negative. 3 plus 4 is 1, so it's plus 1. So you see our properties still hold, that two parallel lines have the same gradient, but different intercept. Let us do another example, example 2, where we have a line which is given by y is equals to half x plus 1, and a line parallel to this line passes through points 2, 5, which I can just call it as point L to 5. And we already know parallel lines have the same gradient, so the gradient of this line is the same as the gradient of this line. So if this one I call it m is negative half, also the gradient of this one, which I can call m1, is also negative half. So to find the equation of this line, I can also call this one x1 and this one y1. And from there, I have my formula where I said y minus y1 is equals to m into x minus x1. So I apply y minus y1, which is 5, is equals to m, which I don't know is negative half, into x minus x1, which is 2. So I get y minus 5 is equals to negative half x plus, when I multiply this one with this one, I cancel 2 by 2, it becomes negative 1. Then when I multiply by this negative 1, it becomes positive 1. So y is equals to negative half. Then when I take this negative 5 to the other side, it becomes plus 5, so it becomes plus 6. So you see, these lines have the same gradient, but the y-intercept are not the same, holding our properties of parallel lines. So bye for now. Let's meet in the next lesson. We check out equations of perpendicular lines.